My name is Rohit Sharma. I am assistant professor in Chandigarh Business School of Administration in CGC Landra. Our topic is on number system in computer. And we get to know in our lecture that how we can enter the numbers in our computer. Computer cannot understand simple numbers. They cannot understand, the computer cannot understand the alphabets, numbers, symbols. Computer understand only 0 and 1 form. So in our lecture we understand how computer understand all these words. So number system and their representation. In digital computers, the user input is first converted and transmitted as electrical pulses that can be represented by two unique states, on and off. So computer understand only two things, on and off. But on and off is represented as 1 and 0. So on is 1 and off is 0. The sequence of on S and on S of forms the electrical signal that the computer can understand. So we have various kind of number system throughout the decades, and these are mainly four type of number system: decimal number system, and binary number system, octal number system, hexadecimal number system. So as the name suggested that decimal number system is we use in our daily routine 0 to 9, and binary number system 0 to 1, octal number system is 0 to 7, and hexadecimal number system is 0 to 9 and then A to F. We will discuss it in further lecture. So in our next slide, we have type of number system as discussed in previous lecture. So the term decimal is derived from Latin prefix deci. Deci means 10. In our school time, we used to learn about the deci system. Deci means the 10 number system, which means 10. Decimal number system has 10 digits ranging from 0 to 9. Because this system has 10 digits, it's also called a base 10 number. So we in our lecture, we also get to know that what is the base system in computer system. Use two digits, namely 1 and base 10 number system, denary number system. So next number system is binary number system. It uses 1 and 0 as discussed in previous slide. Octal is a 8-digit number system, that is 0 to 7. But now the tricky part is hexadecimal number system, a base 16 number system, and that consists of 16 digits ranging from 0 to 9 and letter A to F. So why we are using A to F? Why we don't use 10, 11, 12, 13, 14, 15? So we will discuss it. So in this lecture, we discuss about why we use A to F. So when we write hexadecimal number system, we used to write 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If we write 10, so computer don't understand it as 10. Computer take it as 1, 0, and after that 1, 1, computer take it as 1, 1. So it is very difficult for computer to differentiate between 1, 1 and this 1, 1. So 1, 0 is this 1, 0. So to make this type of problem easier, so we use A for 10, 11 for B, 12 for C, 13 for D, 14 E, and 15 F. So we use 0 to 15, 16 number in hexadecimal system. Hexa is 6, decimal is 10. So this is type of number system that is used in computer system. Now for the next part, we use binary numbers. So this is the tricky parts. How computer understand your things. Computer converts each and every number into 0 and 1 form. So in our normal number system, we write 0, 1, 2, 3, 4, 5, 6, 7, 8. So means we use just numbers, but in computer understand only 0 and 1. So in computer system, this is the tricky part we need to learn about. So in computer system, 0 plus 0 is equal to 0. That is a normal thing. and 1 plus 0 is equal to 0. That is also a normal thing. 0 plus 1 is equal to 1. Sorry, 1 plus 0 is equal to 1 and 0 plus 1 is equal to 1. But the fourth tricky part is that computer understand 1 plus 1 is equal to. Now, 0 plus 0 is equal to 0, 1 plus 0 is equal to 1, 0 plus 1 is equal to 1. But what is 1 plus 1? Computer don't understand 2. Computer just understands 0 and 1. So 1 plus 1 is 1, 0. If you understand this term, you can easily understand all these terms, all the conversion, octal to binary, binary to decimal, everything. So 1 plus 1 is equal to 1, 0. So 0 means 0, 0. 1 means 0, 1. 2 means 1, 0. Why? Because 2, what is 2? 2 is 1 plus 1. So 1 plus 1 is 1, 0. Now 3 is 1, 1. How? 2 is 1, 0. And 2 plus 1 is equal to 3. So 1 plus 1, 0 is equal to 0 plus 1, 1, 1. So 3 is 1, 1. And 4 is 3 is 1, 1 plus 1 is equal to 4. So 1, 1 and 1. Now, this is the tricky part. 1, 1 is 1, 0. So we should carry that 1 on the other side. So 1, 1 is 1, 0. That is 1, 0, 0. So if you write 4 in your computer, the computer understand it like 1, 0, 0. It is not 100. It is 1, 0, 0. So 4 is a 1, 0, 0 for computer. And 5 is, we only just add 1 after 1. 5 is 1, 0 plus 1, 1, 0, 1. So 5 is 1, 0, 1. 6 is 1, 1, 0. 7 is 1, 1, 1. And 8 is 1, 0, 0. So we can count any number just by simple adding. But only one is a tricky thing is, computer use I actually, for your simplifying, I am using this again. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is 1, 0. This is just a simple method that computer is using. But it is a tricky part. Nobody can understand without this calculation 1 plus 1. So, we can move further. In the next slide, we have convert binary number to octal number. So, if you understand the binary numbers 0 and 1 and their calculations, that is just 1 plus 1 is equal to 1, 0. So, you can easily convert binary to octal. So what is octal? So, what is octal? In octal number, we are using 0, 1, 2, 3, 4, 5, 6, 7. These are 8 numbers. So octals are 8 numbers. Computer can understand octal number, but always computer use binary language. So octal numbers are 0 to 7. 0 to 7. So 0 to 7s are 8 number. There is some tricky things in hexadecimal and octal and binary and decimal. When you use binary, you can write 0 or 1, just one line, one number, sorry. And when you use decimal, you use 2 numbers. When you use octal, you use 3 numbers. And when you use hexadecimal, you use 4 numbers. How is that? It is very simple, as I show you in my previous slide. In hexadecimal, 0, 0, 0, 0 plus 1. 0 plus 1, 1, 0, 0, 0. So if you, the 0 in front of 1 has no value. So it is just 1. But we are writing it as hexadecimal. So we are using 4 digits. Okay. But if we are, this is hexa. If we are using 0, 0, 0 plus 1, 0, 0, 0 plus 1, 0 plus 1, 1, 0, 0. We are using 3 digits. So it is octal. You can understand it easily. So there is a difference between the hexadecimal and octal. You should write 4 digit in hexadecimal and 3 digit in octal. So it is very simple concept. Now we can convert this number to octal. So first we have to understand why we put 2 in here, because this is binary number. This is binary number. This is binary number. So binary number we use just 2 numbers, 0 and 1. Because binary numbers are 2, so its base value is 2. So you can understand it easily, because binary numbers has base value of 2. We have to convert it in octal. So octal has base value of 8. It is very simple. It is very simple to convert decimal number, to convert binary number into octal. How we can convert that? So this number is 1010101001. We need to convert this number into octal. How we can convert? As I said, the octal numbers have 3 digits. So you have to differentiate these numbers into 3 digits. So we always start from last. So we can take last 3 digit 101. After that 010, after that 101. These are 3 digits pair. Why we are taking 3 digits pair? Because octal number always use 3 digits. So that's why I said earlier that octal number uses 3 digit and hexadecimal uses 4 digit. So 101, 010 and 101. Okay? Now how we convert this number into octal? So as we saw earlier that, look, in our slide 101 is 5, 101 is 5, 101 is 5. Okay, and 101 is 5 and 10 is 2. 10 is can be written as 010. So 010 is also 2. 10 is also 2, because there is no value of 0 before 1. No value of 0 if we write it in front of 1. So 101, 010 is 2 and 101 is 5. 101 is 5. So for moving further, so now 101 is now, so 101 is 5 and 010 is 2. So in the next slide, we can easily convert these number into octal numbers. So 101 is 5 and 010 is 2. So 101 is 5. So we can easily write that number 101, 5, 010, 2 and 101, 5. So 5 to 5 in octal, 5 to 5 in octal form. So we convert that our binary number into octal form with a simple calculation. But first of all, you need to remember the calculation method. 0 plus 0, 0. So 0 plus 1, 1. Okay? So 0 is written as 0, 1 is written as 1, 2 is written as 1, 0, 3 is written as 1, 1, 4 is written as 1, 0, 0, 5 is written as 1, 0, 1. So these just 6 numbers. You can calculate a binary to octal easily. So after that this number, so 1 1 1 1 1 1 1 1, this is in binary form, we have to convert in octal form, so we have to do it in a 3-digit formula. So we have to write 1 1 1 in separate pair, 1 1 1 in separate pair, so last 1 1 in separate pair. So it is very simple. So this 1 1 1 1 1 1 1 1 in separate pair. So we can easily calculate. So 5 is 101, 6 is 110, and 7 is 111. How I calculated all these numbers? It is very simple, just adding 1 to the previous number. So this is 7 is 111. So 111 is 7. 111 is 7 and 11 is 3. So it is very easy to convert the binary number into octal number. So you can understand it easily. In the next slide, we convert binary number into hexadecimal. So by conversion of binary to hexadecimal, we need to have the pair of 4. In octal, we have the pair of 3, and in hexadecimal, we have the pair of 4. So these are our numbers in binary form: 10 10 10 0 0 101. So this is our binary number, and we have to convert it in hexadecimal. So how it can be possible? It can be done by just giving the four number pair: 0 1 0 1, 0 1 0 1, and the last one is single, because we always start from the last side. Okay, 0 1 0 1 0 1 0 1 1. So 0 1 0 1 0 1 0 1, and last is 1. We cannot write this number is as 1. We need to have 4 number pair. So we can write this one as 0 0 0 1. So 0 1 0 1 is what? 101, because 0 has no value. So 101 is 5, as I told you earlier, and 101 is also 5, and 1 is 1. Okay, so this is 1, this is 5, this is 5. We have our hexadecimal number that is converted from our binary system. So it is very easy thing. Now after that, 1 1 1 1 1 1 1 1 into hexadecimal. So it is also very simple. We need to get the 4 number pair. That is 1 1 1 1 1 1 1 1. These are 4 number pairs. So 1 1 1 1 1 1 1 1. How it can be just the fifth? Ab dekho, why we are writing 1 1 1 1 as 15? How we can go to 15? Because we are writing. Okay. We don't use that calculation. We have our calculation in the previous slides. Okay. Now 15 is 1 1 1 1. How 15 is 1 1 1 1? Now we just calculate 5 is 101, and 5 plus 1 is 110. Just adding 1. 7 is 111. 8 is 100. So by adding all these numbers, we can get 15 we will get 15 as 1 1 1 1. So it is very simple thing. Okay. Now, so now 1 1 1 1 is 15. 1 1 1 is 15. As we know, there is some simple trick. There is some simple trick. Look, 0 is a 0. 0 is 0. 4 is a 1 0 0. 8 is 1000. Okay. 16 is 10000. So by this formula, you can easily get the numbers. So we need to find 111. So we can start from 8. So 8 is 1000. 9 is 100, just add 1. 10 is 10, just add 1, 10. 11 is 1011. 12 is 1100. 13 is 1101. 14 is 1110. And 15 is 111. We can get any numbers with this formula. So this is just nothing. 4 is 2's square, 8 is 2's cube, that is 2's 2 raised to power 4, and 2 raised to power 5 is 32. So we can get 32 by this number. So it is very simple calculation. Okay, so you can go with this calculation. So 111 is 15, 15, but computer cannot understand 15. So for 15 we use 10, 11, 12, 13, 14, 15. As I mentioned earlier, 10 is A, B, C, D, E, F. So 15 is F, 16. So FF, why we write 16 in the base? Because in hexadecimal number we use base 16. Okay, so it is very simple thing. So in the next slide, so now there is another conversion. We can get the binary numbers and we can get the octal numbers, etc. So we have to convert a binary number into decimal number. So we have our binary number 110110. So we have to convert it in decimal. So there is a simple formula that we learned in our schools. Very simple formula is that every number that has power 0 is equal to 1. So if you find 2 raised to power 0, it means it is equal to 1. Any number, 1 raised to power 0, 1. 2 raised to power 0, 1. If you have 0 raised to power 0, it is also equal to 1. So any number that has power 0 is equal to 1. If you have alphabet is like A raised to power 0, that is equal to 1. X raised to power 0, that is equal to 1. So it is very simple to understand. If any number, I cannot say anything, but you can say anything has raised to power 0 is equal to 1. So 2 raised to power 0 is equal to 1. 2 raised to power 1 is equal to 2. 2 raised to power 2 is equal to 2 into 2, that is 4. 2 raised to power 3 is equal to 2 into 2 into 2 is equal to 18. 2 raised to power 4 is equal to 16. 2 raised to power 5 is equal to 32. 2 raised to power 2 is equal to 64. 2 raised to power 7 is equal to 128. 2 raised to power 8 is equal to 256. 2 raised to power 9 is equal to 512. And the last is 2 raised to power 10 is equal to 1024. 1024 is very important number in computer system. You can remember as 1 MB is equal to 1024 KB. 1 GB is equal to 1024 MB. So 10 raised to power 10 is equal to 1024. So it is very simple calculation. Now, how we convert a binary number into decimal number? So we have a number 110. That is in binary. We have to convert it in decimal. So we can write down in this way 110 as you see on the above. So we always start from this side, the last side, that is 0. So we always take 2 raised to power 0 first. 2 raised to power 0. 2 raised to power 1, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4 and 5. In this way, we can move further, and we have to multiply these powers with the numbers as we see above. Last number is 0, so 2 raised to power 0 into 0. Next number is 1, 2 raised to power 1 into 1. Next number is also 1, 2 raised to power 2 into 1. Next number is 0, 2 raised to power 3 is equal to 0. Next number is 1, 2 raised to power 4 into 1. Next number is also 1, 2 raised to power 5 into 1. Now, we just calculate this number. Now, any number that is multiplied by 0 is equal to 0. This number is 0. 2 raised to power 1 is 2 into 1 is equal to 2. We have to add these numbers. Now, 2 raised to power 4, 2 is 4 into 1 is 4. Okay? 0, you don't have to multiply that number, because any number is multiplied by 0 is equal to 0. So 2 raised to power 4 is 16 into 1. Now 2 raised to power 5 is 32, 32 into 1, 32. Look, there is a simple part in that. Every number is a multiplier 0, 1, because it is in binary number. So you always have to multiply it with the 0 or 1. If you have to multiply it with 0, you need to write down 0. If you have to multiply it by 1, just write the number as it is. So 32 plus 16 plus 0 plus 4 plus 2, that is 54. So it is very simple calculation, not a tricky thing. Just now, why we take 2 raised to power 0? Why we take 2 raised to power 1? Why we take 2? Because we are using binary numbers. If you are using octal numbers, we have to take the powers of 8. So this is the thing. Now, in the next slide, convert 262. The 262 have base 10. It means it is a decimal number, and we have to convert decimal number into binary number. How can we convert this decimal number into binary number? It is very simple thing. We do. If you see any decimal number, convert into any number. If you see any decimal number convert into any number, you always use LCM method. When we convert just decimal number, when we convert a decimal number into binary number, we have to use LCM method. So it is very simple method, because 262 is a decimal number, we need to convert in binary. So first we take simple thing. First we take 262, we have to divide it by 2, because we are converting it into decimal number. So we divide by 2, we get 131. When we divide 262 by 2, we get 131, and the remainder is 0. Remainder is 0. After that, 131 divided by 2, 131 divided by 2, we get 165, and the remainder is 1. And after that, 65 is divided by 2, we get 32, and remainder is 1. And 32 is divided by 2, and we get 16, and remainder is 0. After that, 16 is divided by 2, and we get 8, and remainder is 0. And 8 is divided by 2, 4, 0, 4 is divided by 2, 2, remainder is 0. Now 2 is divided by 2, we get 1, and remainder is 0. So we have 1 left, and we have to write it as 1. So this is the tricky part. All the calculation is based on dividend and remainder. So we need to just divide by 2 and get the remainder. After we always get 1 as a remainder. We always get 1 as a remainder. So that 1 We cannot escape that one. We cannot left that one. We have to write it at the last. Write it in the last. That one is placed at one this side. So to write that number, we use upward method. We use upward method to write that number. So last is 1, 1 2 3 4 5. 5 times 0, 1 1 0, 1 1 0. So this is our binary number. So if you write 262 in computer take it as 100000110. So computer understand only 0 1. 262 is equal to this number. As 262 divided by 2, we get all these numbers and we get all these remainders. Only one tricky thing is that you have to take last one into the downward side, but to write in binary form, you take always upward side. So 100000110, that is our binary number. So it is very simple. Now the next slide. So it is just a simple method. We can convert any binary number to decimal, or any decimal number into binary or octal or hexadecimal. So it is very simple thing. This is our second last slide, simple slide. So we need to convert this decimal number into octal number. So 34 is our, how can we identify this is a, this 34 can be written in decimal also. 34 can be written in octal also. 34 can be written in hexadecimal also. How can we identify that? Just by putting the base. So 10 base is decimal, 8 base is octal, and 16 base is hexadecimal. So we need to convert that decimal number into octal. So the simple same method as we convert decimal into binary, we use 2 as divider in binary, but we use 8 as divider. 34 inside and 8 when 34 when divided by 8, we get 2 as remainder, because 8 4s are 32, and 4 is now 4 is cannot be divided to 4, so 4 can be take as it is 4. So we use always upward method 4 2, that is octal. So it is simple as that. And 456 into octal. 456 is divided by 8, we get 57. We get 57 and remainder is 0, and 57 is divided by 8, we get 7 and 1 is remainder. So 7 is written as it is. So 710 is our octal. So you can understand easily. The last slide, decimal to hexadecimal. So this is our last slide. Very simple. The last question. Convert 255 decimal into hexadecimal. So we use the same method, hexadecimal in conversion. 255 when divided by 16, we get 15, and 15 as remainder, and 15 cannot be divided by 16, so we take 15 as it is. So 15 15 upward method, 15 15 is FF, that is 6, that is your hexadecimal. So we can convert our decimal number into binary, into octal, into hexadecimal in the similar LCM method, but watch carefully, you need to convert decimal to any number with LCM method. Okay, so this is our last slide. I think you can understand it very easily, very well. So thank you all.